Hello everyone, I'm Steve Nichols and welcome to our interactive briefing. We're pleased so many of you are joining us today. But first, a little housekeeping before we get started. We're going to hear from 3 experts today. I'm sure you have lots of questions, but we're going to save those for the end of the briefing. You can use the chat feature to ask questions and we'll try to get to as many as we can. We're recording this briefing and the video will be made available soon after the event. So let's get started. Those of you working with head of state and VIP operators know that there are many considerations relating to installing IFE and in-flight connectivity solutions that are unique to large airframes and the VIPs themselves. As the world opens up, world leader and VIP travel will continue to ramp up again. They will want to communicate in flight, and of course, you're going to want to be ready for that. The challenges to implementing secure, high-quality IFE and connectivity on large airframes are many, which is why we're going to cover key concerns related to aircraft used by VVIPs and world leaders. We'll highlight not only the important technical and customization considerations you'll need to think about when embracing an installation, but also provide a brief overview of future satellite technology. To help us explore this topic, I'm joined by Jamie Palmer, BGA Sales Director, and Stuart Gilpin, Design and Systems Engineer from Eclipse Global Connectivity. Eclipse, as you may know, are connectivity experts with more than 25 years experience ensuring VIPs, heads of state and military aircraft can be connected in flight. Also with us today is Jacques Salvat, business developer at Display Interactive. DI offers unique and comprehensive IFE solutions to commercial and business aircraft through its Yugo Wireless IFE app. So let's get started with IFE and Jacques.
Thank you very much, Steve. So my name is Jacques. I am business developer at Display Interactive, and I'll be presenting today our VIP solution, which is Display Executive. So Display Interactive has 2 main products: Yugo for commercial aircraft, airlines, etc., and has been flying for many years and is well known around the industry. But a few years back, Display Interactive has focused its development on VIP section and head of state aircraft. And with that, we have our new product called Display Executive. Display Executive is currently equipped and flying also on a few aircraft around the world. So as you can see in this slide, and thanks to our collaboration with Eclipse Global Connectivity, Display is able to deliver the whole IFEC chain of value, and from the portal to the content going up to the service and the operation of the system. So today I'll be focusing on this, and in a few minutes, Jamie and Stuart will describe what they do best. Before we go into details, I'd like to describe how we deliver our product to the customers. So by installing a server embedded in the aircraft and with wireless access point distributed throughout the cabin, we're able to distribute our software to the aircraft. If the aircraft is equipped with connectivity, we integrate to this architecture, and throughout the same portal, we distribute both the IFE and the connectivity. This slide represents the typical architecture on the 737 BBJ. So now let's focus on what's inside the server. So our software, our IFEC software, is actually used to distribute all of the content and the service to customers. So for example, if you have a VIP section in the aircraft, we're able to have in this zone wall-mounted screens, wireless access points so that the passengers can access using their own devices to the server, and we can distribute iPads for more premium content. This system is also able to distribute different services. So we have many services out there. One that we're very proud of is our own moving map that has been in-house developed and is able to be fully customizable depending on the customer's recommendation or requirements. And also, for all of you out there who are really looking out on the moving map market, we're able to go at a very high level of zoom. So for 1 pixel, we're able to do 5 meters. So if the aircraft is also divided into different sections. And if you'd like to have a rear cabin service or an economy class service, we're able to have the same product, but in different types of sections. So if you have for the economy class seats, where we can have like the same product, but with less content, for example, or no connectivity, or different GUI, different aspects, so we can tailor to your cabins. Concretely, this is actually this slide sums it all up, the scalability of our product. So as I said, in the economy class, you're able to have the passenger devices connected to the architecture with certain services and certain content. In business class or VIP zone, we're able to equip with more wall-mounted screens to have a better experience of the content, the moving map, have also different flight sequence, such as landing and takeoff phases, where, for example, you have a broadcast of special messages, destination information, or even the moving map that I'm going to be showing to you in a minute. Or in the VIP section, we're able to increase the service with iPads distributed to customers so that you can have early window movie, which enables a better content experience. So this is our standard interface that I would like to show you. It is used as a demo. Everything you can see on this is, of course, customizable. So you have a first section, which is movies, then a second section with audios, the moving map, which you call the air map, files, so you could be able to broadcast your own files onto the aircraft, onto the screens, and TweetDeck, which is basically a tweet information, so Twitter information coming up using the connectivity. So if we focus on, for example, videos, you have a normal video section, you have movies and series. These can be updated using hard disk provided to the aircraft and uploaded onto the server. And then you have, for example, breaking news and information at destination. These sections can also be updated using the connectivity. They are lighter and they enable to have a more premium and a more updated experience for the customers. I'm going to show you the audio. For example, here the audio has no difference and no different section. We're able, of course, to distribute it as genres, or as different countries, etc., etc. And the air map is animated. It has very sleek information, very limited. We're able to add more information, have different views, focus on different areas, etc. But most of our customers enjoy this very simple interface with very clear information. And as you can see, the experience and the quality of the image is very good. This moving map can be shown as a, for example, takeoff or landing scene. Okay. That's it for me.
Okay, thanks, Jack. Now, just one question. There are a lot of players in this market with similar solutions. So what makes yours different? What makes it the best on the market then?
That's a very good question. And indeed, there are a lot of players in the market. So I think what makes Display Interactive and Display Executive very different from the other players in the market is first and foremost that we're able to adapt to our customers' needs. This means that when we have a requirement, we bring an off-the-shelf product, but this product, because it's a software and not a hardware, we're able to develop new functions to enable us to meet our customer's requirement. And we always listen to what the customer wants. But we also bring all of the experience that we have in developing software solution. So this means that we will focus on bringing a software that is easy to operate, easy to update, and makes both the operation teams and the customers happy. And last but not least, I think what's interesting is that we adapt to the existing architecture of the aircraft. So if the aircraft is connected with connectivity, we're not going to bring a new solution and a new architecture. We're going to try and adapt and embed our software in the existing server so that the customer, throughout one unique portal, can reach both IFE and the connectivity. And of course, I think what I can add is that Display Interactive is always looking towards the future, always adapting, and we're listening to the market. So each time a customer has a requirement that can beneficiate to other customers, we're implementing it and updating our software constantly.
Okay, thanks, Jacques. That was very enlightening. So now that we have a view into IFE, let's turn to Jamie to talk about in-flight connectivity.
Thanks, Steve. Good afternoon. My name is Jamie Palmer, and after Jack's excellent overview of Display Executive, I'm now going to cover the C in IFEC, connectivity, and continue to keep us all in the fast lane. Without giving away my age, I've been in the Satcom industry for not far off a quarter of a century, which means I remember the heady days and the excitement of the launch of Inmarsat Swift 64 and making one of the first very grainy video calls back in 2001. These days, things have changed a lot, and the evolution of high bandwidth connectivity systems over the last 10 years has been incredible. And I want to talk to you about some of the issues that the implementation of these high bandwidth connectivity systems can bring. Now, I'm sure you will be familiar with this image because many companies connected with airborne connectivity like to use this to promote their products or services. It's the dream. It's the happy customer basking in sunshine, multitasking on his personal device, laptop open. And as I say, this is the dream. It's 2021. It's the same year that NASA has sent a remote control helicopter to Mars, it's controlled it on Mars. So surely reliable global internet to an aircraft should be possible today. Well, unfortunately, not in all cases. I hasten to add, JetBlue is not an Eclipse global connectivity customer. Our typical end customers are heads of state, prime ministers, presidents. But the issues seen on this flight is not uncommon for heads of state. JetBlue made internet on board, or let's say in-flight Wi-Fi free back in January 2017 for all of their passengers, which is excellent news. Certainly the passengers would have thought this was excellent news. But unfortunately, this results in the poor experience that these passengers have suffered back in 2018 on this flight. Now, I wasn't on this flight, but I can imagine it's a busy sector. It's, New York to Los Angeles. So I can well imagine that there are 150 people on board this aircraft, or potentially all trying to access the internet because it's free. And so what happens is frustration, as been written up in this example, frustration. And these customers may have only spent $100 on their seat, but they expect connectivity. And like Jacques explained with Display Executive, heads of state demand the very best IFE and connectivity. So the aircraft, let's say the VIP aircraft, head of state aircraft, is equipped with the very latest high bandwidth connectivity. Typically, it will be KU or KA band. And this is what the end customer expects. This image that I'm showing you right now. A fast, open connection with no roadblocks. Okay. So whenever I'm speaking with a customer, an MRO or an end customer, I'm always keen to ensure that their perception is correct. In my experience, there is often a misalignment with the end customer's expectations of what high bandwidth connectivity is going to bring to his aircraft. Like with the JetBlue passengers, they expected connectivity. And for VIP aircraft, terms like office in the sky that has proliferated our industry for a very, very long time have really brought the reality brought the perception to end customers that they can have the same experience in their aircraft as they perhaps can in their office, or indeed perhaps in the home. But unfortunately, the laws of physics don't permit that today, and we'll come on to more about the laws of physics later. So in reality, what is usually seen or experienced is this. And this is just a demonstration, really, or using a graphic. But what is seen on the aircraft is typically congestion, contention, and ultimately frustration. During the pandemic and the lockdowns, the reliance of everyday life on connectivity increased. We all learnt new terms. I'm quite sure 18 months ago, not many people knew what to Zoom meant. Your home internet connection will likely have been used for your work, maybe that of your partner, the schoolwork for your children, online gaming, accessing Netflix, grocery shopping, and all of the above. And of course, this was the very same for your neighbours next door, who are quite possibly connected into the very same ground infrastructure as you. And so it's completely clear that the ground infrastructures would become overloaded at times, and slow internet was experienced, and the end result being frustration. And heads of state and their aircraft are not immune to this experience. So how can Eclipse help with solving this problem? Well, this is a typical head of state aircraft LOPA, with a VIP section, taking up the most of the front part of the fuselage, and then some guest accommodation for perhaps traveling entourage or media, and then of course the area for the crew, notably the pilots at the front, but maybe a galley area as well. So let's say that this particular aircraft has a passenger load of 30 people, including the crew. But this will likely mean there is nearly 100 wireless devices on board that aircraft. I can lay my hand very quickly around me to my iPhone, a wireless device, to a tablet, a wireless device, and also to a laptop PC, a wireless device. This is not unusual, so I think any passenger load should be times by 3 to get an idea of the number of wireless devices that will be connected. Plus, there'll be the additional ones that are on the aircraft, perhaps for displaying iPads for showing magazines and newspapers. So 100 is not a bad sort of guess for this aircraft with 30 passengers. But the very best high bandwidth connectivity solution will offer 20 megabits at best to the entire aircraft, which at first seems plenty, but if you divide that by 100 devices, the results can be kilobits per device. For aircraft equipped with Inmarsat SBB back in the day, management of the bandwidth inside the aircraft was possible for heads of state. You could dedicate the VIP exclusive use of an entire SBB channel in streaming mode, for example, and then the rest of the aircraft could be running background, and the VIP would not be affected in any way when anyone else was on the aircraft. But that isn't the case today. So with high bandwidth connectivity solutions, now there is one single relatively fat pipe arriving at the wireless router, and on a small business jet, control of the Wi-Fi in the cabin can be easy, or let's say managed potentially by, let's say, the giving out wireless passwords, to some people and not to others. But on a large aircraft, on a VIP Boeing 777, this isn't going to work. So in this scenario, you have the situation that you've got a high bandwidth connectivity solution on the aircraft, but the VIP can be affected by the other users. So if there's a guest in the back accessing Netflix, then the VIP is going to have have a poor experience. Equally, high bandwidth solutions, high bandwidth connectivity solutions like KU or KA typically use voice over IP for the voice connectivity. So again, the head of state could be making a voice call, someone's down the back of the aircraft doing just accessing the internet, and yet the head of state's communication is actually getting degraded by that. And then, of course, you've got the guests down the back of the aircraft who essentially could be uncontrolled users. It's not the sort of thing you want to be doing, really, policing access to the internet. And then, of course, you've then got the crew in the front of the aircraft who, have a job to do. And obviously, the job is to get the head of state or VIP safely to the end destination. But really, did you want the VIP's internet experience to be degraded for the fact that the crew are downloading a high def movie, or perhaps downloading a high def image of the weather for the route that they're flying? Over 3 years ago, Eclipse Global Connectivity quickly recognized that the careful management of the Wi-Fi inside the cabin was required with high bandwidth connectivity solutions. And what came out of this was the development of AeroPlus flexibility. This solution is now deployed across presidential and other heads of state aircraft around the world. And the solution provides many benefits, but what I'm just going to focus on today is the assigning a minimum bandwidth and assigning the priority levels within the cabin for the Wi-Fi. So in this example, there are 3 zones that that I spoke about earlier on the previous slide. So, for example, the VIP can be given a guaranteed minimum bandwidth. So Inmarsat KA band or GX allows you to know a minimum bandwidth level that you're going to be provided on the aircraft. And so it's then possible that you can then actually guarantee that the VIP is going to receive a minimum bandwidth using the AeroPlus flexibility software. The voice over IP can also be guaranteed. So you can have a crystal clear digital quality voice service off the aircraft at all times, regardless of any of the other internet activity that's going on the aircraft. The guests in the back of the aircraft, or the media, or the entourage, can have an adjustable bandwidth, and perhaps that can be done on a mission basis. So they might have a lot of bandwidth if they're on one particular mission, but then on another they might have a relatively low one, and that can be dynamically managed by the cabin crew or the associated flying engineer on the aircraft very quickly. And then, of course, the crew at the front can also have adjustable bandwidth, again, mission dependent. One of my favorite features of the AeroPlus flexibility is actually the ability to offer charging out to some passengers or all passengers. So, for example, if this was a VIP operator and his aircraft got chartered out on the odd occasion, then perhaps on the chartered route, it could be very easy for the aircraft to be configured for all of the passengers to have to pay for the internet access on board. Whereas the return leg could be very easily an owner flight where the owner and the family were then traveling back. And again, at a very quick swipe of the iPad, it would be easy to reconfigure the aircraft back to that open access for them. And to my final slide, here I provide the main features of AeroPlus flexibility and a reminder that the solution is software-based. Much like Jacques and Display Executive solution, it is a software base that resides on the airborne wireless router. But the ground components are equally important, with a complete end-to-end service being offered. So for our current head of state customer base, Inmarsat GX has typically been the chosen technology. So the slide that I'm showing you here actually shows Inmarsat on there, and it also shows that there's a GX Satcom and an SBB Satcom, or a Swift Broadband Satcom. So one of the other benefits of the AeroPlus flexibility solution is an automatic fallback. So all systems on aircraft, sometimes are going to fail, and sometimes the service goes down equally. So should the GX service on the aircraft fail due to hardware, or perhaps the service goes down, then there is an automatic fallback to Swift Broadband, where the Swift Broadband service will then kick in and provide service to the VIP, obviously at a limited level, but will still provide service. And without wanting to steal my colleague Stu's presentation a little later, you can see that down in the bottom of the screen, there are several other key elements that have been designed into the Eclipse ground infrastructure to ensure that our heads of state customers receive the service that they expect. So, for example, direct interconnects into Inmarsat, providing assurance of security and also, speed to make sure that there's no delays. But equally, there's one key one in the bottom there, customer interconnects. A lot of our customers are heads of state, and they have their own security policies, and they sometimes want of course, a secure link directly out of our facility. So it's either possible for us to make that happen through our facility, or as Stu will explain later, we can actually replicate this infrastructure in their own facility. So in summary, in my experience, it's not the technology that is failing when a VIP or head of state experiences frustration in the internet experience on board the aircraft. Most often it is the implementation of the cabin wireless architecture, or indeed the management of the network. So Eclipse and AeroPlus flexibility prevent this from happening and ultimately result in a happy customer. So thanks very much.
Okay, thanks, Jamie. One quick question though. You talked a lot there about Inmarsat GX Aviation, which obviously has a headline speed of 50 megabits per second. But what in reality do customers expect to see in terms of connectivity speeds, and how much do they actually need?
Yeah, thanks, Steve. That's a really good question, because you're right. Inmarsat are not alone in this. Obviously, Inmarsat's headline is the 50 megabits per second, but actually it's the same for the other operators. So Viasat, GoGo 2KU, they all publish large numbers, because that's kind of what actually is the hook to get people actually interested or to sign up for their service. So Inmarsat, so it's not wrong that 50 megabits is possible with a fuselage mount antenna and the current version of GX avionics. However, I think what needs to be remembered is that Inmarsat's aviation customers are not only the only customers to Inmarsat. So they have the maritime customers, and they also have land customers as well. So if Inmarsat were to offer 50 megabits to an aircraft, it would quite quickly run out of capacity in, let's say, a spot beam and over a densely flown area like Europe, for example. So they tend to limit that down. So typically, Inmarsat's GX is limited down to 20 megabits is the most that a VIP or business aviation customer can sign up to today. And to go back to your question on how much do they typically need, well, if you're web surfing, you probably only need a couple of megabits, really, depending on what you're doing. But if you're emailing, not even megabits. But if you're, let's say, wanting to have a reliable Netflix experience, then I think you need to be looking at perhaps 10 megabits and up, really, because it's generally the case that you will not get 10 megabits for the entire flight. There will be occasions when it dips below, but of course that would be my recommendation.
Okay, very interesting. I'm amazed these large implementations are often so complicated. So anyway, thanks very much. Let's now complete the picture by looking in more detail at the technical and security aspects of implementing connectivity in IFE. No doubt you've all heard about cybersecurity issues in the news, and I think we can agree that nowhere is it more important than on a head of state aircraft for connectivity to be secure. So Stu, why don't you dive in and tell us a little bit more about cybersecurity?
Hi, thanks, Steve. My name's Stuart Gilpin. Like Jamie, I've been in the industry for around 25 years. Took a couple of years out, but found myself drawn back by the challenges of aviation. So the first thing I have to say is we live in exciting times, dynamic times. If you think about my career, I started in the 90s with base 10.2 coax communication. We then moved to Ethernet, 10-bit, 100-bit, gigabit. So everything's changing. Hardware is changing. The technology is evolving so fast. But the problem is the life cycle of the aircraft is every 2 years. It takes 2 years to get what you have at home onto an aircraft, because you have to build it, test it, certify it. So the problem we've always had is, how do you have all the new toys, all the old tools, and still keep yourself secure? The thing here is security is key, but it's also the way you build your network that helps you fulfill that. So if we talk about connectivity, we said about coax, we said about Ethernet, but there's also the wireless to consider now. Wireless in the 90s and early 2000s was 11 megabits, which was good for, as Jamie said, web browsing, the basics. But as time has evolved, applications have evolved. We have things like Netflix, which needs now high definition streaming. So you need to use the later wireless Ns, wireless ACs. Currently my house has wireless X, the Wi-Fi 6 as they call it now, which is twice the speed that we have on an aircraft, and I still get throttling when I'm watching on the TV. Bluetooth, that's a little bit more confusing. So if you think of Bluetooth speeds being 1 to 5, they're not. I think 1 to 3 is the generation of speed, and 4 and 5 about low power. So on an aircraft, you really want to think 1 to 3. That gives you the longest distance for the shortest battery life on a device. Once you've decided what connectivity you need, 3G, 4G, Ethernet, Wi-Fi, you need to think about that speed I was talking about. On an aircraft, we have walls. So if you're streaming video, you need to use the higher end 5G, the 5 gigahertz. But the problem with 5 gigahertz is it's broken down by walls, especially bulkheads. Solid bulkheads on an aircraft will stop it. It just block it completely. In which case, you have to put in more WAPs. But if you're not using the high streaming, then you can switch to the 2.4 gigahertz network and probably cover the entire of a 321 with 2 WAPs. So that's another thing we've got to think about now is when you're building it, do you need speed or do you need the distance? And that leads us on to topology and then scalability. Once you decide how you're going to build it, you need to think how you're going to connect it. Is everything going to run in serial, parallel? Will you daisy chain to save weight, to save cabling? Is there enough space to have everything paralleled off? But scalability is the bigger question. What happens when in 3 months' time he wants to add more to his VIP aircraft? Or he designs it for communication and then wants Jack's video service. So you have to think, build it so it's expandable, but also build reliability. Availability is one thing, but reliability, redundancy is key to keep this network up. Jamie said sometimes you have problems with the link not giving you the full 10 megabits during a flight. That can happen on the plane as well. WAPs get congested internally, so many devices locking in. So you have to think about that as well. Once you've got your reliability, you need to secure your network. All right, security we're talking about here, we're just talking about things like passwords. Wi-Fi's need passwords. Unless you have a payment portal with credentials, lock everything down. Introduce VLANs if you can. And if you can get it, WIPs. Wireless intrusion protection protects each user from being hacked by another user. Once you have everything done, make sure it's compatible. The problem we have now is everything is evolving so fast. Technologies are moving, but aircraft still have old technology. 4-wire telephones are still in existence on most aircraft. 2-wire is a bit more common. Some even have ISDN, and you need an adapter now because ISDN is dead. So think about that. Then move on to the software. You need to be able to divide these zones and control each zone. Give a bandwidth to a zone. Block websites from a zone. Each zone needs to be controlled. The software needs to be able to do this. The software also needs to secure the network. Can it provide the VLANs as discussed in network security? There's no point in securing the whole network on the aircraft if the software sticks it all in one bundle and throws it over the Satcom. Does it provide the additional services? We talked about web browsing, Netflix, but there's other things, voice. You can have payment portals, e-shopping, anything else. You need to think, does the software support this? And does the support the apps that you want to use? Apps are in our everyday lives now. I don't think anybody can say they don't use an app. Facebook, Pinterest, you name it, it's there. So let's forget about all of that now and move on to an aircraft. As Jamie said, let's pick a narrow body aircraft with a VIP lounge area. It's got a couple of walls. It's got an office, a bathroom. How do you build it? If it's got a Satcom and a primary router, how do you make sure that he gets what he wants? Well, obviously, everybody knows the VIP is going to have a mobile phone, maybe an iPad and a laptop. So he's going to want the Wi-Fi. And 2 to cover his aircraft because he might want to wander down the back. So cover the aircraft with the WAPs. But also think about Ethernet. If the WAPs go down, Do you have a backup plan? Could you wire up an Ethernet port to his desk in his office or beside the bed in the bedroom? So once you've done that, the one thing most people seem to forget is a patch panel. Put a patch panel in somewhere. It doesn't matter where. It doesn't matter if it's in the bottom of a cupboard, but it's there for a reason. If the world goes horribly wrong on your aircraft, you can disconnect everything and plug in a carry-on router. Or, as we found with a lot of VIPs these days, you can plug in a crypto unit, slaving it in and securing the link. Then think about your others. Think about your guests and your crew after the VIP is done. Once you have them on board, once you have all the networks sorted, then start thinking about your redundancy. WAPs have multiple Ethernet ports now, so why not slave a backup cable? You can lock it out in the router and only enable it if needed, or you can have them running together. You can have a clear and a secure network in the VIP zone, both with separate SSIDs. Then your software bundles it up and sends it out to the Satcom in a secure way. You'll notice it's encrypted in a tunnel. Jamie mentioned as well about secondary Satcoms. I just want to point out, secondary Satcoms are fine for backups, but they're limited in their bandwidth. And you have to remember this when you do your backup. So the VIP is the most important person on that aircraft. There's no point in putting everybody over a SBB background channel. Nobody will get connected. So think about that when you do it. How do you want this done? Do you want it just for the VIP or just for the crew? When we move on to smaller aircraft, you're not going to have the space and possibly not the budget for all of the WAPs, all of the backup, all of the redundancy. So the other option here is to use these WAPs to share the network, remembering to make sure the SSIDs are locked and separate to each bridge, to each network, and that they can't cross between the two. And this is where your WIPs is very handy. And if you haven't got WIPs, make sure you're running VLANs on each network. So we have our aircraft sorted, we're done, but we're not. The satellite network, whether it's Inmarsat, Viasat, Intelsat, it's pretty seamless. The only thing it's going to add is a little bit of latency, maybe a bit of jitter for your voice over IP communication. But apart from that, it's transparent. It's when you hit the ground, you've got your issues. Again, you need to think about security and applications. So can they provide you with all of the services you want? Your payment portal for your crew if they need it for the access. And finally, the VIP. Can they provide you with a secure link to the ground and then directly forwarded to the customer site and still give you all the services? Payment portal for the guests, weather map filtering for the crew, file transfer, voice over IP, acceleration, everything that you really need. But can they also provide that securely in your site? Now, we have developed for certain customers an entire range of hardware solutions and virtual machines that we can give them to put in their ground network and run so that they're basically having all the services that we have in our ground network virtually hosted at their own network, just to provide things like secure voice over IP. So you can have a secure phone line in the VIP network that is encrypted all the way to the ground through the secure line to their office, where it's decrypted and then put onto the public network inside that office. It's great for governments and heads of state. They do like that. So that's me. Thank you very much.
Okay, thanks. So a quick question then. So in terms of cyber security, how risky is in-flight connectivity on a head of state aircraft?
Ooh, well, I suppose with all forms of communication, there's risk. Governments tend to like to sniff packets on the internet, hackers. It's very much the same as you would in any open environment. And Eclipse started with military customers. So we quickly became aware that securing the end-to-end link was the best way to go. So I suppose identifying the main risks would probably be three or four. I mean, internet packet sniffing, I just said then. Over a satellite link, that's almost impossible because the way that the modems work. But once it hits the ground, it is open on the internet. So securing it with a minimum of a VIP, a VPN, or for a VIP, something like a Storm Shield, which is NATO standard encryption, right up to a mini Catapan, a high rate encryption device. There's also a risk on the aircraft. So some aircraft have VIPs on board, but they also have the pack of reporters they fly around on the back. And here you have to think about wireless packet sniffing rather than the internet. So that's probably a bigger risk than that. So this is where the WIPs and the VLANs come in handy. And then, of course, there's device hacking, which that's malware. So for firewalls for that and filtering. So that has to be in the ground section just to protect the aircraft. So I suppose to sum it up, there is a risk, but if you analyze it and mitigate it, it's probably a lot safer than going to a hotel or an internet cafe.
Okay, thanks, Stu. That was a very interesting overview. Talk about complex. Security is one of those ever-changing issues that needs to be addressed and addressed well. You really can't afford to get it wrong, can you? But now we're going to look at the future. Jamie is going to give us a quick overview of what's coming up in terms of satellite technology. So over to you, Jamie.
Thank you very much, Steve. I will just bring up the presentation. 1 second, it's just coming up now. So thanks very much, Steve. As I say, here at Eclipse, connectivity is all we do, and keeping an eye on the future is something that we do to ensure you and your customers are best informed, and frankly, that you don't have to keep an eye across all of these changing and complex technologies that Stu's just described. I'm going to spend the last session giving you a peek into the future of airborne connectivity and what you can look forward to for the coming years. So first of all, I'd like to start with the Inmarsat GX roadmap. Arguably, Inmarsat offers the best service for a head of state operator with few satellite handovers, all operated by one company, and those satellites were built exclusively for Inmarsat and Inmarsat's customers. You may also know that Inmarsat has recently, in the last 18 months, gone back into private ownership, and the good news of that is that there is now a fully funded roadmap with multiple satellite launches in the next 2 or 3 years. So this slide here that I'm showing you now has all of their roadmap clearly marked out, but a couple of key points that I wanted to to highlight to you. Firstly, you're probably very familiar with the ring that goes round at the outside with most of the satellites on there. But if you focus on GX10A and 10B, they're actually HEO satellites, so not GEO satellites that Inmarsat usually uses, geostationaries. These ones are highly elliptical orbit satellites, and those satellites are going to be providing polar coverage from 2022. So for any aircraft that have polar routes flying up over the Arctic, then those satellites will be able to provide you coverage. Today, Inmarsat's GX service typically provides service between 70 north and 70 south. But once these HEOs come online, then it will be available beyond 70 north. Another point to mention is that GX6, GX6A and 6B, these are dual payloads. So they are L-band and Ka-band, which just goes to further enhance Inmarsat's commitment to L-band for safety of service and cockpit use. And then the final point I wanted to make on this slide was that GX7, and 8 and 9, those satellites are going to go up, and actually each of those satellites has the same capacity as the total GX network today. So GX1 to 5, which are operational today, once GX7 goes up, it will actually double that capacity. I think it's just incredible to think about that, but obviously satellite technology has moved on just like everything else has, and when GX1 went up, that was probably on the drawing board almost 10 years ago. So things move on, but ultimately for the end customer, I think you can see that there will be a lot more bandwidth to come from the Inmarsat constellations. So I'd just like to move on, but before I mention Viasat, so I'll say to you that there are other solutions out there, not only Inmarsat, of course, for high bandwidth connectivity. For example, you could, heads of state are flying with Panasonic or Gogo 2KU, but these have typically not been developed for VIP or head of state operators. They've typically been developed for the airline markets, and their roadmaps are largely tailored to the increasing the bandwidth on the major air corridors rather than providing, specific global coverage. So I just wanted to cover off Viasat really, which may not be someone that you're familiar with for head of state. They have always had a business jet solution, but notably Viasat do have a head of state customer in Air Force One. Mostly Viasat I think Viasat's original offering was KU band based, where multiple satellites, are overlaid to provide global coverage. But interestingly, what they're now looking to do with with Viasat 3 is they're moving to Ka band, and you can see on this slide here that they are going to have global coverage with, frankly, 3 geostationary satellites, and then there'll be some infill. You can see on this slide where they could use partner satellites or some of their own satellites to provide additional capacity. So partner satellites like ChinaSat, for example. Unfortunately, with the pandemic, Viasat 3 is not available yet, and the first launch, the CEO has announced earlier this year that it will be in 2022. So with the second and third going up in 2023. So I think Viasat is certainly one to watch, certainly competition for Inmarsat in that regard. Moving on to Iridium, which is probably one that you're also very familiar with in the aviation industry. But there's not such good news to tell on Iridium. Iridium have obviously are great for providing small antennas and solutions to business jet aircraft, but even their very latest Iridium Next, which has been long awaited, frankly, the upgrade to the old Iridium constellation. Their Certus product, which is their broadband product, as you can see here on the right, actually is only going to provide a maximum of 700 kilobits. So not really broadband, and certainly not broadband as we would expect it, and not something I would probably recommend as the primary solution for a head of state aircraft. So I'm not looking to make rocket scientists out of you all, but I really wanted to give you an overview of some of the other technologies that are out there, because, and I've mentioned HEOs, highly elliptical orbit satellites. I've also mentioned GEOs, geostationary satellites, but there's also LEOs, LEO satellites, low Earth orbit, MEOs, middle Earth orbit satellites. And really, Iridium is a good example of a LEO satellite. So the benefit of, as you come down in altitude, so LEOs are at 500 to 2,000 kilometers altitude, MEOs 2,000 up to 36,000, and then the GEOs, like the Inmarsat and Viasat ones, will be at 36,000 kilometers. The benefit of low Earth orbit and medium Earth orbit satellites is lower latency, and typically smaller antennas. So excellent, to be able to install them on an aircraft. But on the downside, you require more satellites because the satellites are closer to the Earth, so they're spinning around the Earth that much quicker. You need more ground stations typically to cover them, more satellite handovers, and more complexity. However, I'll just cover off a couple of the points on this slide. So you're probably quite familiar with Elon Musk. So Elon Musk has created SpaceX, Starlink. So Starlink has certainly the most satellites available in space today. Elon Musk has already launched 1,750 satellites, which is quite astounding, bearing in mind that's almost half of the commercially available satellites that are orbiting space currently. There are 4,500 satellites orbiting or thereabouts. So Elon doesn't have, he has getting on for half of them. He has 42,000 in his plan, but actually the FAA have only approved 12,000. And for aviation, he absolutely has said that there will be an offering. It's just that there is scant detail on that as yet. Moving on to Telesat and Amazon Kuiper, little is known about those yet, and certainly Amazon Kuiper are yet to launch. But I wouldn't certainly take any, wouldn't bet against Jeff Bezos making a success out of something. So that's one to keep an eye on. Finally, on the right-hand side is OneWeb, which is more, let's say, the one that I think it has more to offer the aviation industry in the immediate future. You'll probably be aware that OneWeb is now owned by the British government and also an Indian telecoms company. Eutelsat have also, I understand, recently bought in a shareholding. So the OneWeb satellites are LEO satellites, and they are at 12,000 kilometers. Sorry, 1,200 kilometers, 1,200 kilometers altitude. Tomorrow sees quite a historic launch for them, actually. So at this time tomorrow, if you're interested, there is a OneWeb launch tomorrow, which will see 36 more satellites go into space, giving them a total of 254 of a planned 650 that they require for the complete constellation. What that 254 will enable them to do is that at the end of this year, they will have a service launched where fixed terminals, so terminals on the ground and to remote villages, will be able to receive service for if they are located anywhere above 50 degrees north in latitude, so all the way up to the Arctic. Going further forward, they have a very aggressive schedule for releasing new satellites and launching those, and they have a target of the second half of 2022 for global service. And then they have actually selected an aero terminal partner already, so those will be tested, no doubt, during 2022. The latter part, and then they aim to have everything running for those terminals in 2023. And moving on to my final slide, really it is about ESAs, or electronically steered arrays, or most of us will probably know them as flat panel antennas. The future is flat panel antennas. So they offer less drag, less fuel burn, less weight, arguably. They are more reliable with no or few moving parts. And then on an aesthetic basis, they're not as ugly for the owner to slap onto the top of the fuselage. These antennas, some of them are available on the open market today, but big companies are looking into this market. So you have Collins, you have ThinCom, Kest, Nextcom, Isotropic Systems. But this technology is not without its cost, and it's expensive to get into this new level of technology. And you may be familiar with a company that was offering an antenna called Phaser. And this was a flat panel antenna that they were going to offer out, certainly for the aero market as well. But unfortunately, they ran out of money. And the latest from Phaser is that they were actually bought by a South Korean defense company. So ESA technology is used in L-band and SBB antennas today. So as I say, it's not brand new technology, but it's the drawback really with it using geostationary satellites is that the look angles to the satellite is limited, because physically, you know, it just doesn't look around the sides of the aircraft quite like a mechanically steered antenna does. Again, physics is against us. But this is the direction, surely, for the future of connectivity. But as always, Eclipse will continue to keep a close eye on what the future options are available for our customers. And as soon as kit is available, the one thing that we always do is bring it into our test lab and get our engineers to fully pore over it before we actually offer it as a solution to our customers. So thanks very much.
Right, thanks, Jamie. That's it for the formal presentations. Well, now, I'm sure you've all got questions for our experts. So simply type your question into the chat bar and hit submit, and we'll try to get through as many of your questions as possible. So do get typing now, and we'll see what comes up. I think our people are busy behind the scenes reading them and getting them onto the screen. Nothing yet? Okay. Jamie, if you're still there, it's interesting. We were talking about coverage over the poles with geosats, and you were talking about Inmarsat and their highly elliptical orbit satellites. But of course, when OneWeb eventually gets its service up and running, that will naturally have coverage over the poles, won't it?
Absolutely, it will, Steve. You're right. So the interesting part of Inmarsat's HEO deployment is actually that they are deploying it, but they're actually deploying they're deploying these HEOs, but they will actually only give coverage to the North Pole. So they don't see a use right now for having coverage covering the Southern Pole and the Antarctic, but certainly a lot of airlines today do make the route across the top of the world, across the Arctic, and they see a benefit in having connectivity there. And you're right, certainly OneWeb solution, the way that the OneWeb satellites work is that they orbit the Earth very quickly, frankly. I think each satellite is going to be orbiting the Earth at roughly every 3 or 4 hours. So they will be covering in a mesh around the world and giving complete global coverage. As I say, the complexities, and I think what is yet to be fully tested, is how the handovers will work, certainly between satellites, between the multiple ground stations, but equally between and how will that affect the user experience on board the aircraft? Because obviously, if you are flying on an aircraft, or a head of state is flying on an aircraft, and they're watching a movie, or they're watching Netflix or whatever, they don't want that experience to be, let's say, cut or for an interruption. So during a satellite handover, and with LEO technology, there are so many more satellite handovers that will need to take place during a flight.
Absolutely. Okay, thanks. Right, do we have any questions? Have they been moderated and posted?
Yeah, we have 2 questions.
Excellent.
From Dean, I think. First question, and I think that's maybe for Stu.
Yeah, I suppose I better take this one. Right, so currently we are on the Contron, the Optelity. When I say the Contron, there's 2 or 3. There's the 6000 series, 608. There's also the 9 series, 905, 906. We've got it on an Optelity and on a Quadrant box as well. So there's 3 or 4 at the moment, but we're sort of evolving it onto different platforms as we go. Dean, if you've got any specific platform in mind, let us know, and we'll take a look at it. We'll put it in the queue.
Excellent. Thanks, Stu. Thanks, Dean.
And second question from Dean as well, and I think this one is going to be more for me. So, Dean, if you're talking as like platforms in terms of aircraft, basically any aircraft can be equipped with a server and wireless access points. So we can be offered on every type of aircraft. If you're talking platforms in terms of actual servers that we work with, we've worked with a lot throughout the industry. There are many players out there, but our preferred solution for reliability and operation ease is definitely Contron. And it's also the best also for in terms of integration, connectivity, etc. But any player out there, we've actually worked with and collaborated with. So I hope that answers your question.
Okay, I've just seen the clock and it's coming up for 2 o'clock. So we've done this timing absolutely perfectly. Any more questions? If not, I think we'll have to close the meeting down.
One more has just come in. Sorry, I'm just going to. In fact, we've got 2 more that have just come in very quickly. Let me just bring 2 in. Jack, there's one for you.
Yes, DRM. I'll take this one.
Yep.
So okay, the DRM is covered by display, and when we broadcast and when we upload the content to a server, the server automatically reads the encryption and the encoding of the content. So the content is 100% DRM protected, especially as we do the streaming, as we do the streaming device. But that's also why we have iPad services. So we distribute tablets to allow our customers to broadcast not via streaming, but only on tablets, early window content and more like Hollywood content that would not be DRM protected. So yes, we are DRM licensed. That's very important for a lot of platforms out there, and content protection is definitely a key issue.
Thanks, Jack. I do see one other one. I'm having difficulties with the technology and publishing it, but the question was, what is your typical implementation time for a G650 if it will take delivery? It will take delivery. Oh, there we go. Someone's put it up for me. There we go. Thank you. It will take delivery of a new aircraft, never been operated before. Robbie, I think I can cover this one off. Frankly, we need to get, I think the best solution is that we get involved the earliest possible, mainly because it's good to actually involve exactly what is required at the end on the ground, or what the end customer requirements are. I would say a typical implementation time probably can be as short as a couple of months. It really depends what the requirements are. If the customer does require the equipment that is actually in their own facility, then that is going to take us longer to actually make that happen. But certainly if it was an interconnect into our facility connecting to a head of state's facility somewhere, then it is possible for us to make that quicker than that. So I hope that gives you some guidance. Sorry to not be firm on implementation times. And we do have one last one, Steve, that's come in. I'm just about to publish it too.
Yeah, I can see it. Yeah.
So I'll just read it out. According to the new EASA rules, the operators have to improve the avionics systems of their aircraft. Can the SBB system support the navigation system with the needed data? Stuart, I think I'm going to pass this to you, but as far as I'm not so familiar with those EASA rules, and perhaps we could take that offline with Isfan. But are you familiar with those?
Yeah, I would like to take it offline with Isfan, because I'm not sure how he's. It's a bit the wording. There's so many different answers I could give, and I don't want to give the wrong one. But if Isfan, we'll come in, we'll get in contact with you, and we'll chat about it on offline. Get a bit more detail on that one.
Okay, so I think that means we wrap it up.
Absolutely.
Just checking. Okay, all right. Well, that was great. So thanks for your questions and participation today. Just a reminder, we've recorded this event and it will be shared with everyone shortly. If we didn't get to your question, as Stu said, we'll get back to you directly. And again, thanks for all your time. Oh, look at that. A question just came up, I think.
Yeah, well, I'll take it with Dean as well later on.
Yeah, okay. So again, thanks for all your time. I've certainly learned a lot, and I hope you have too. And we'll see you next time. So goodbye.
Thank you, everybody.
Thank you.